Okay, so today we're going to focus on permutations. We're also going to look at some new buttons on your calculator and learn a little more about factorial notation with permutations. Okay, so to start with, we're going to find that new button on your calculator. So for factorial, what that actually means, and it's a 4 with an exclamation mark, is it is equivalent to 4 times 3 times 2 times 1. So you start at whatever numbers attached to that factorial sign, and then you're just moving down by one whole number until you get to 1. So on your calculator, what you'll do is you will go to Math, and then when you're on the Math screen, you'll move over to Probability, and you'll choose that factorial symbol, which is number 4. So for me, I forgot to type the 4 in, so I would type math, over to probability, and then option 4. And I end up with an answer of 24. There we go. All right, let's try typing some of the rest in our calculator. So 3 factorial times 2 factorial. So we would just type 3 factorial times 2 factorial. Press enter, we end up with 12 as our answer. And then we'll try the next one, 4 factorial divided by 2 factorial. So we have 4 factorial divided by 2 factorial. Okay, and we end up with 12. And the last question, it says, determine the number of arrangements that 6 children can form while lining up to drink. So the last lesson, using the fundamental counting principle, we would have drawn out 6 spaces, and then we would start by saying we have 6 kids to arrange, then 5, then 4, then 3, then 2, then 1. With factorial notation, instead of typing this all into our calculator, this expression is the same as 6 factorial. So we can just type 6 factorial into our calculator. And we end up with an answer of 720. Okay, so with the factorial symbol now, let's see if we can write some equations that are equivalent using the factorial notation. So 5 times 4 times 3 times 4, 5 times 4 times 3, right? When you look at this statement, you'll notice that it's missing the 2 and the 1. So what we're going to do is we're going to write 5 factorial, and then we're actually going to divide that by 2 factorial. What that ends up doing is if you were to take 5 times 4 times 3 times 2 times 1, 2 factorial is just 2 times 1. It ends up canceling the 2 times 1 from that numerator, which just leaves you with a 5 times 4 times 3. That's what we want in order for these two expressions to be equivalent. So in this next example, we start, if we just look at the numerator, we'll just start by looking at the numerator. You started with 12 factorial, and then we went down 11, 10, and then we're missing the 9. So we have to divide by 9 factorial in order to cancel what's missing. So now that we've looked at the numerator, let's focus on the denominator. So the denominator is just 5 factorial, right? 5 times 4 times 3 times 2 times 1. So we're just going to go ahead and add that to our denominator. And again, another easy way to double check, if you type this in your calculator, it should be equivalent to the expression using factorial notation, and that's how you know you did it right. However, when you type it in, make sure you put brackets around your denominator or you will end up with the incorrect answer. So now we are going to use this idea of factorial notation and solve. So if I have n factorial, okay, what that means is I can take that n factorial and then just go down by 1. And really, I could go as long as I want, and then I could just put a factorial on the end, because we actually don't know what n is. N could be any number, so you could keep going as far as you needed to. So here, with that n factorial, I am going to replace it with the n minus 1, and then I'm going to stop at n minus 2. The reason I'm stopping at n minus 2 is because I want to cancel that denominator out. Okay, so at this point, because remember, you still have that factorial symbol on the numerator, even when you expand it, it's still going to be at the end. But because I have an n minus 2 factorial and an n minus 2 factorial, I can actually cancel those out. The reason being is because the expression in front of that factorial symbol is equivalent. So now I have n bracket n minus 1 equals 90. And from here I can solve for n. So I'm going to distribute that n, and I end up with n squared minus n equals 90. Then I'll subtract the 90 over to the left-hand side here, and then I'll factor. So two numbers that multiply to give me negative 90 and add to give me negative 1 are negative 10 and positive 9. So then if I solve for each of those factors, on the left side here I'd have n equals 10, and on the right side I'd have n equals negative 9, and those would be my solutions. So we're not quite done yet, because another fact about factorials is because factorials represent arrangements, you can't arrange negative numbers, you can't arrange negative things. So that means this negative 9 is an extraneous root, so my only solution would be that positive 10. Okay, let's try the one over here now. So my first step, I'm just gonna keep going with this n factorial. I'm gonna go down by 1 until I get to n minus 2, so that I can cancel the factorial. So now I can cancel that n minus 2 with the factorial symbol, and with this one I can also cancel an n, which means all I'm left with is n minus 1 equals 42, and from here I can solve. So I can bring that n over to the right side, which gives me an answer of n equals 43. Okay, so now that we're working with permutations, determine the number of permutations of the letters. So again, you could use the fundamental counting principle if you wanted. That's absolutely fine. You could count the letters in Regina, 1, 2, 3, 4, 5, 6, and you could draw all 6 spaces out, and then you could write, using the fundamental counting principle, figure out all of the different ways to arrange Regina. So that's one way to do this question. You can also use a factorial. So on my calculator I could type 6 factorial, which I actually think we just did that, didn't we? Yeah, 720. So that gives me an answer of 720. So that factorial symbol is just another way to solve this question. So with Kelowna, I have 1, 2, 3, 4, 5, 6, 7. So again, I could use the fundamental counting principle to arrange all 7 of those letters, or I could just type 7 factorial into my calculator. Okay, and I end up with 5,040. 5,040. Great. All right, next question. This is on your formula sheet. So it looks really complicated, but I'm going to explain to you what it means by using an example here. So first of all, this P represents permutation. So when you see NPR, what it means is the N would represent the total amount of objects, and the R would represent the number that you're arranging. So in this example here, it says determine how many 3-letter arrangements can be made from the letters of the word graphite. So in the word graphite, we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 letters in the word graphite. We are arranging 3 of them. So we would write 8p3. So on my calculator, I'm going to go 8, and then I'm going to take the math symbol, move over to probability. This time I'm going to choose option 2, which is NPR. Oh, and then it looks like I have to type the 8 here, so I'm going to have to delete this other 8 on this calculator. Let me just try typing that in again. All right, all calculators are a little different. You'll have to see which or how to do this on your calculator. So 8p3 gives me 336. Okay, so what that means in this formula is 8p3 equals n factorial, which is your 8, over n minus r, which is 3. So 8 minus 3 is 5 factorial. So they're saying if you were to type this in your calculator, you would also get 336. Okay, you could also solve this with the fundamental counting principle. You'd have your 3 spaces, 8 options, 7 options, 6 options. If you were to type this in your calculator, you should also get 336. Okay, so I'm actually going to go back to this last slide. I just want to show you something here. Now that we know about the permutation button, you could have, instead of writing 6 factorial, you could have also written it as a permutation. So 6 factorial is the same as if I were to have 6 objects and I'm arranging all 6. So let's go back to our calculator and try typing that in. So we're going to go to math, over to probability. If I were to type 6, arrange 6, I end up with the exact same answer, 720. So yet another way that you can express this particular solution to this question. Okay, not too much you need to worry about on this slide. We're not going to worry about this. Pretty much you can read it if you want, but 0 factorial equals 1. Okay, that's the main idea that you need to know. All right, let's try another question. In a region, vehicle license plates consist of 2 different letters followed by 2 different digits. So I'm going to underline the word or highlight the word different. 2 different letters, 2 different digits. If the letters I, O, and Y, and Z are not used, determine how many different license plates are possible. So I'm first going to use the fundamental counting principle. Okay, so I'm going to have a letter, then a digit, then a digit. Okay, so I have 1, 2, 3, 4 letters, okay, that I can't use. So there's 26 letters in the alphabet. If there's 4 that I can't use, that means there's 22 letters that I can use. I've used one of those letters, which means I have 21 letters left over. Okay, because it says different digits, that's how I know that I can't repeat a letter, or different letters, sorry. For digits, I can use any digit from 0 to 9, so there's 10 different digits that I can use. I've already used a digit, so that means there are 9 left. So on my calculator, I would just type 22 times 21 times 10 times 9. And my answer is 41,580. Okay, so we can also express this answer using permutations. So with permutations, our first permutation, we're going to focus on the letters. So there's 22 letters we can arrange, and we're only arranging 2 of them. And we are also arranging digits. So there's 10 digits we can arrange, and once again, we're arranging 2 of them. So let's try typing this in our calculator. So we're going to type, and I'm going to put this in brackets. I guess I don't really need to. So I'm going to go to math. On my other calculator, I have to put it in brackets. Now choose option 2, 22 letters, arranging 2, and then I'm going to multiply. Go back to math. Oh dear, I might have to try typing that in again. So I'm going to go to math, over to probability, 22, arrange 2, there we go, times, back to math, over to probability, 10, arrange 2. Awesome, and I get 41,580, which was the same as my last one. So again, just another way to express that answer. There are some questions to try. Once again, I highly recommend that you try some because this unit is all about being able to read questions, and let me know if you need any help.